All right, this problem is a classic work problem. We've got two people who can paint a house in a certain amount of time. And typically the question you're asked at the end of this problem is, how long is it going to take them to paint the house together? So we're actually just going to define some different variables throughout this problem. And then it's going to prompt us to think about this as a rational equation and to work with that. So it says it takes Akio 9 hours to paint a house by himself. It takes Julia 10 hours to paint the same house by herself. Okay, and then we're going to let T represent the time spent painting for the entire job. So we have this table over here. I like to actually define the variable first. So the time spent painting the entire job, it's right here. So I'm going to enter that T in. And, it doesn't matter if it's Akio or Julia doing it. They're both going to spend T hours. And you can see as you fill in the table on the right, the table on the left is going to get filled in for you as they tell you here. All right, so for the entire job, that T represents that. So T represents the time, the amount of hours for the entire job by Akio and by Julia. So the rate of painting by Akio, so Akio is painting, it takes him 9 hours to paint a house. Now remember, that's not a rate. Okay, a rate, you got to think of sort of like a speed. The big equation that you should have in the back of your mind for all of these problems is distance equals rate times time. So our rate, if we were to solve for rate and distance equals rate times time, is the distance divided by the time. So the distance in this case is a house, right? So how many houses? So what's the portion of the house painted? Painting one whole house, right? That's supposed to go in here. And so my rate of painting is the distance divided by the time. So if it takes Akio 9 hours, then his rate is one whole house in 9 hours. So that 1/9 is what's going there. And hopefully you can apply that same concept there for Akio, for Julia. So if it takes her 10 hours to paint the house by herself, then her rate is 1/10. So one whole house in 10 hours, right? Think about rate. It's like when I say speed, it's like miles per hour. So this is, in this case, it's house per hour or hours. All right, so then the next piece of information we want to define here is the rate of painting. Well, let's just go back and think about the rate of painting for each of them. If it's one whole house in however many hours they paint, if we were to define that for the entire job, which we can express the time spent painting the entire job with the variable T, then our rate of painting is just going to be one whole house in T hours. You can see that here. So we have Akio's rate of painting, Julia's rate of painting, and then the rate for the entire job. All right, and then our time spent painting is T for everybody. And then lastly, we want to define the portion of the house we're painting. So the portion, that's our distance. So when we think of distance equals rate times time, I know it's hard to probably grasp that painting a house aligns with distance, but if you think about it, almost it's the goal we want to reach. So the distance is going to be our rate times time, where D equals RT, and so we can actually we can use T to describe the portion of the house painted by Akio and Julia if we think about it in terms of these rates here. So the portion of the house by Akio is going to be T divided by 9. And for Julia, T divided by 10. Okay, so this is like our time, the time it takes, almost our rate again. So now this is where I said it's going to prompt you with a question here. So it wants us to write an equation that can be solved for T the time spent painting for the entire job. So if I'm gonna I want to define an expression that I can solve for t. Now I want to look over at this chart that it's filled in, and let's look at the portion of the house, because we want the portion of the house painted by a Keo. So this is where you have to be a little bit creative. If we have the entire job is going to be one whole house, and I took away Julia's time spent painting, then I'm going to get a Keo's, right? Because they're splitting the job. So a Keo's time spent painting, or the portion of the house he paints plus the portion of the house Julia paints, is going to get us the entire house. So if I take away Julia's portion, then I end up with a Keo. So I can write in this expression 1 take away t divided by 10. And so if I want to take that expression and I want to use that to write an equation so that I can solve for the time spent painting for the entire job. So remember in the beginning, I asked you, or I told you that this was going to be typically, how long is it going to take them to paint the house together? That's what we're going to figure out right now from creating this equation. So I'm going to take that expression I just wrote, and we said that that is equal to the portion of the house painted by a Keo, which is t over 9. And there's an equation now I can use to solve for t, and they actually do it for us. So even though it takes a Keo 9 hours to paint a house by himself and Julia 10 hours to paint a house by herself, together it will only take them almost 4 3/4 hours. A common mistake a lot of people make is they just add the 9 and the 10 hours. Painting together, it's actually going to take them less time, right? All right, so use this example to help you complete a work problem in this section.